Alright, so now we're dealing with chemical bonding. So, forming and representing compounds, we have a basic set of knowledge that we need to know. So, scientists have studied the way in which elements and compounds appear in nature. So, in order to categorize chemical bonding, we know that most metals are combined with nonmetals in nature, and they are called ores, which are solids. Okay, so we have some examples here. Alright, so these are examples of ores which are found in nature, which are a combination of metals and nonmetals. Okay, we also have here, so few metals are found in their pure form, and these tend to be precious metals. Okay, so we have, for instance, we've got gold here, and we've got some other ones here. So all metals except for mercury in their pure form are solids. Okay, mercury in its pure form is a liquid. Here we have nonmetals, combine with one another to form solids, liquids, or gases. Okay, so here are some examples of some nonmetals. The only elements that are never found in combined form in nature are the noble gases. Okay? Atoms, gain, lose, or share electrons in such a way that they create, that should be a full outer energy level. And this is called the octet rule. This is something that we looked at slightly in our last set of videos. And we just kind of said that it existed. That was kind of all that we had talked about. So the first energy level can only hold 2 electrons, and therefore it satisfies the octet rule when it has 2 electrons in it. The octet rule is a guideline, so not all elements follow it all of the time. So we know that valence electrons are in the outermost energy level of an atom. They are the only electrons involved in chemical bonding. Okay, so it's not anything other than the valence electrons, because the other ones are so close to the nucleus that they don't really do much of anything, and they are satisfying the octet rule, all in their specific shells rather than the valence electrons. Okay. So for representative elements, so group 1, 2, and 13 to 18, the group number, so if you ignore the one in front of the groups above the 10, it tells you the number of valence electrons. Okay? The period number tells you the number of energy levels occupied by electrons. So, for many transitional metals, the number of valence electrons is not as predictable, and it depends on the environment around the ion. Okay, so this is something again that we had talked about. Again, that's using, do I use iron 2 or do I use iron 3? That sort of thing. And again, here's our examples, right? So iron can be found as iron 3 or iron 2. So the iron charge can be used to determine the number of valence electrons. So for example, iron 3 has 3 valence electrons. Now we're going to deal with electron dot diagrams. So you can't see atoms and electrons, therefore it is convenient for us to draw models in order to show the structure and formation of chemical bonds. So an electron dot diagram is such a model, and it consists of the symbol of the element with the dots that represent the valence electrons. When drawing diagrams, we need to look up the number of valence electrons and then place the dots around the symbol clockwise for a maximum of 4 dots. Okay? Now, we're going to look into this more into the next set of notes.